Okay, students, for those of you that may have been absent or those of you that want a refresher on balancing equations, this is what we did last week in science class. So I have a simple chemical equation that I've written out. We have sodium plus chlorine gives us table salt, sodium chloride. Chlorine is always written as Cl2 because it's one of those diatomic atoms that's always paired up with itself. Chlorine, oxygen, nitrogen, hydrogen, fluorine, these always travel in pairs. So we have to write it as Cl2. We have a sodium, we have sodium chloride. Now, things on the left side of the equation have to equal things on the right side of the equation. Nothing gets lost. We have this law called conservation of mass. And so all the atoms that are on the left have to be present on the right. We can't just lose things. Another rule we have, we can't change any subscripts. We can't add any of these lowercase drop-down numbers that we call the subscript. We can't add them in to balance anything out. Otherwise, it would be real simple to just say, oh, I'll just put a 2 there. But you can't do that because sodium and chlorine don't bond that way. And we'll see why in another activity in the very near future. So the only thing we can add into a formula once it's been written down is what we call a coefficient. And that is a number that goes in front of the atoms or the molecules that tell us how many of those are present. So if I put a 2 right here, that would say that there are 2 NaCl's in that equation. So here's one way you can do this. Some people will just look at it and keep track in their head of how many are on the left and the right, and they'll start putting numbers down and count them up. Another way you can do this is just label what is on each side of the equation. So we have a sodium and a chlorine. And on the other side, we have the same stuff. Sodium, and we'll tell Siri to be quiet, and a chlorine. Because we have to have the same thing on the left as on the right. So how many sodiums are on this side? 1. How many chlorines are on this side? There's 2. How many sodiums are on this side? There's 1. How many sodiums are on this side, or chlorines are on this side? There's 1. So when we look at this, we can tell immediately what's not in balance. Sodiums are in balance. There's 1 here and there's 1 here. But chlorine, there's 2 here and there's only 1 here. So we're going to need to increase this to 2. And like I said, the only way to do that is to put a 2 right there. Now that's going to change our numbers. So on this side, nothing's changed over here yet. But on this side, we've now got 2 sodiums, and we've also got 2 chlorines because this 2 gets distributed to everything that's in that molecule. So 2 of these, 2 of those. Now these are in balance, but these are not in balance. I've got 2 there, and I've got 1 there. So I'm going to throw a 2 right there. And now that's going to change my number of sodiums. I've now got 2 sodiums and 2 chlorines, 2 sodiums and 2 chlorines. Now my equation is balanced. 2 sodiums plus 1 Cl2 gives us 2 sodium chlorides. And that's balanced. Let's try another one. Okay, here we have another formula, and we've got elements on the left, elements on the right that are not in balance. So let's just write down what we have. We have silver, which is Ag. We have hydrogen, and we have sulfur. And on the other side, we have to have the exact same stuff. We have Ag, hydrogen, and sulfur. Now, let's count them up. Silver, we've got 1. Hydrogen, we've got 2. Sulfur, we've got 1. On this side, silver, we've got 2. Sulfur, we've got 1. And hydrogen, we've got 2. So when we look at this initially, hydrogen's in balance, sulfur's in balance, but the silver is not. So how are we going to change that? Well, since silver is the only thing out of balance, we're just going to put a 2 here, right? And then we're going to see that's going to be a 2 now. Now we've got 2, 2, and 1. We balance that whole thing by putting a 2 there. Sometimes they literally are that easy. All right, let's try one that's a little more difficult. Okay, now we've got a bunch more stuff. We've got a potassium. We've got an oxygen. We've got a hydrogen, and we've got carbon, and we've got oxygen there too, so we got to make sure we count all those. So we've got 4 different elements on the left. That means we have to have 4 different elements on the right. K, O, H, and C. Now, let's count them up. There's 1 K, and this is where sometimes you have to be careful. There's 1, 2, 3 oxygens, because you've got 1 in this KOH, and you got 1 in this CO2. You got 2 in the CO2, so that's a total of 3. You've got 1 hydrogen, and you've got 1 carbon. All right, what do we have on the other side? We've got 2 Ks. We've got 4 oxygens. There's 3 there, and there's 1 there. We've got 2 hydrogens, and we've got 1 carbon. So that's the only thing that's actually in balance right now. We've got 1 K, we've got 1 H, we've got 2 K, we've got 2 H, and we've got 4. So I think, just based looking at this, I think the things we should try and balance first, since O's in 2 separate places on both sides, let's try and balance the K's and the H's out first and just see how that works. So if we put a 2 here, that's going to change this to 2 K's. That's going to change this to 4 O's. I don't know why I erased one and crossed one out. Just cross that out. Now we've got 2 H's and we've got 1 C. Did I really just balance another one with just a 2? 2 K's, 2 K's, 4 O's, 3 4 O's, 2 H's, because 2 times 1 is 2, 2 H's, 1 C, 1 C. Ah, I guess that one was that easy too. I thought this was going to be harder. All right, I promise you, the next one is going to be harder. Okay, last one. This better be harder. All right, what do we have? On the left side, we've got aluminum. We've got hydrogen. We've got sulfur, and we've got oxygen. So, on the other side, we're going to have aluminum, hydrogen, sulfur, and oxygen. Let's count them up. Okay, 1 aluminum, 2 hydrogens, 1 sulfur, 4 oxygens, right? Okay, on this side, we've got 2 aluminums. Look at this, we've got 3 of these SO4s. So this 3 is distributed into this parenthesis, into everything that's in the parenthesis. So it's 3 times 1 is 3 sulfurs, and 3 times 4 is 12 oxygen, and there's no other oxygen anywhere else. And we've got 2 hydrogens. So right now the hydrogen is the only thing in balance. So what are we going to do? Since this is 3 SO4s, and we've got SO4 over on this side too, I think we should put a 3 here, just to try that on for size. So I've got 3, so that's going to give me 6 hydrogen. Well, I don't know why I'm racing again. 6 hydrogen, 3 sulfur, and 12 oxygen. And we've got, now that's in balance, that's in balance. This is not in balance. So we've got 2 hydrogen, we've got 6 hydrogen on this side. So we're going to have to put a 3 over here. Okay, now we've got 6 hydrogen. And we've got 2 aluminum on this side, but only 1 aluminum on this side. So we're going to put a 2 over here. And then we're just going to double check. 2 aluminum, 2 aluminum. 3 times 2 is 6 hydrogen. 3 times 1 is 3 sulfur. 3 times 4 is 12 oxygen. 2 aluminum, 3 times 1 is 3 sulfur. 3 times 4 is 12 oxygen. And 3 times 2 is 6 hydrogen. 2, 6, 3, 12. That's balanced. Now, when you have a bunch of numbers at the top, you might want to look at them and make sure, let's say while you were playing around with this, you were messing around, you changed something maybe a little too much, and you ended up with this. Instead of 2, you had a 4. Instead of 3, you had a 6. And you had a 2 here, and you had a 6 here. You had all these different numbers. Okay? Now, count them up, because all these are going to change now. 4 aluminum, 12 hydrogen, 6 sulfur, 24 oxygen. 4, 2 times 3 is 6 sulfur, because it's going to be 3 sulfurs times 2, because it's 2 of these Al2SO43s. So that's 6 sulfur, and then 2 times 4 times 3 is 24 oxygen. And then 6 times 2 is 12 hydrogen. Now, is it balanced? 4, 12, 6, 24. Yes, it is balanced. But everything in here is even. Everything in here is divisible by 2. So you really want to write your answer in the lowest common denominators. So you would still write it as 2, 3, 1, 3. And because we don't have to write the ones, we would just leave that blank. So I just wanted to go over that as another possible outcome while you're balancing equations. Now, if you have any questions, please shoot me an email or ask me in class. See you next week.